take a look at this. Let X and Y be jointly distributed as that. Maybe X here is the proportion of time the working facility is used in a bank by customers, and Y is the proportion of time the drive-in facility is used. Now what the bank official really want to understand here. What is the probability that 25% of the time the driving facility will be used, while 25% of the time the working facility is used? This is the maximum that the working facility is going to be, used within 0 to 25%. And the driving facility also going to be in use, within 25%. That's what we want to figure out now. So here now, we want to find simultaneously the probability of X and Y equal to a realized value. It doesn't matter. This can be, they may not necessarily be the same. 1/4, 1/4, it could be something else. Okay, so what we're going to do here, interpreting that, this is what we need to do. You see that? If I'm starting with the S, you can see the first integral that appear close to the S. This is going to be a sequential integration. I'm going to do this guy first. Do you see that? Then after I'm done with that, then I'm going to go for the second one. And at the end of the day, I'm going to get this result. Is there any question on this? You just need to revisit your knowledge of antiderivative. Okay, now I'm going to move right now. That's how to get it joined. Oh my God, this is going to be complicated. Now take a look at this. You have a function that is not completely specified. Why is not completely specified? Because of K. K is a constant. That K needs to be determined. And not only that, S high lie between 0 and 1. When they say Si lie between 0 and 1, mean X1 lie between 0 and 1, X2 lie between 0 and 1, X3, because here this is a function of X1, X2, X3. Does that make sense? And we have another restriction. Take a look at that. This look like the chemical example that I walked you through the other time. X1 plus S2 plus S3 must be less or equal to 1. Okay, now I need you to pay attention. The very first question said, compute the joint marginal density function of X1 and S3 alone. Let me tell you this. The full one has S1, S2, S3. If I'm interested in just X1 and S3, then it means I'm actually going to marginalize. I'm going to integrate the whole thing over the range of the one I'm not interested in. What am I interested in? I'm interested in S1 and S3. Then I will integrate over the range of X2. Does that make sense? That's how to do it. Okay. Now, let me say here, I want to answer the question that has to do with A here. Okay. Marginal. S1 and S3 out of all of that. Take a look at this. What am I integrating with respect to X2? Because I'm not interested in X2. I only want to focus on S1 and S3. That was what the question talked about. You remember what we did the other time, where whenever you have a restriction, when you want to get a marginal, you got to put into consideration. Solve for S2. Solve for the variable you are not interested in. That will be X2 is going to be 1 minus S3 minus S3. That was why the upper bound is that. Look at that. Is there any question on this? Okay, so I'm doing that in terms of all what you just need to do is to integrate with respect to X2. When you are done with the integration, you're going to plug in the upper bound. The upper bound is going to be 1 minus X1 minus S3, and the lower bound is 0. And at the end of the day, you actually going to get this. Somebody's going to be wondering, where is the K, right? K is a constant. Okay, I've already found the K. How? To be 1/44. So here, before you set for the integration here, you're going to put 1/44. But I want to award an extra credit now. Can somebody tell me, what am I going to do to figure out the K? It's a constant. What am I going to do? I got that K to be 1 over 44, but I did something to get I get K to be 144. What did I do to this to get 144? Go ahead.
You integrated from 0 to 1 with that, and set it equal to 1 after you integrated and figured out what value of K.
How many integrals am I going to have?
Three.
Okay, good job. Then when I do the integral, then I'm gonna put the S1, the S2, the S3, then equal to 1, right? Is that what you mean? Then I suffocate, right? That's correct. Send me a message for extra credit. Now, if you know what I'm gonna advise you to do, try that and see whether you're gonna get K equal to 144. Okay? Now, I'm done with that. Now the next thing now is asking me to do what? Okay. Oh my God. Look at the question B. Let me tell you this. When you get question A wrong, question B will be wrong. You know why? Because when you take a look at question B, you want to use, this is a focusing on S1 and S3. If you want to do something that has to do with S1 and S3, you need a function of S1 and S3. And that was what you derive in A, which means you're actually going to make use of this guy here. If this guy is wrong, then the other one is going to be wrong. And that's why it's easy to score 0 in maths. But when questions are related, maybe you need the result of this guy in the other one. That's why you got to be careful, right? Okay, now what am I going to do now? Okay, I want to solve that. Okay, take a look at this. What am I bringing in? Okay, where is this guy coming from? Oh my God, it's actually coming from here, what we derived before for f of x1, s3, because right now the focus is what is the probability of x1 plus s3 less or equal to 0.5. That's exactly what I'm going to use. Can you see where it comes from? Now the next thing now is to decide on what I'm going to put in the range. Okay, now I put a ds3 here, right? Putting a ds3 means there's an implication of that. Now, please pay attention. If I want to integrate with respect to x3, I need to come here and solve for s3. S3 will be what? When you solve for this, it's going to be 0.5 minus x1. That's why you have that guy here. And, less or equal to that. So 0 to that. You look at the lower bound to that. And when you look at the last one, x1, the x1 will be from 0 to 0.5. The x1, so 0 to 0.5, then you solve that. That's super cool. Now, the next one, let's look at the next question. The next question asks about this. C. Oh my God. That one is asking about x1 only. X1 only. If I want to get for x1 only, I can just come here. Or what I'm just going to do, integrate what out? S3 out. I'm going to integrate S3 out. Okay? Integrating S3 out. Okay? You see that? Integrating S3 out. Okay? Now, at the end of the day, you got a result. Okay? Now, because of my time, I'm going to go to conditional. Okay? We may not finish this material today. We're going to continue from there tomorrow, but we still have like 7 minutes. Now, how do we do joint probability? For joint, don't forget, I gave you the formula for conditional to be that, for continuous, and for discrete. Okay? Now, I got a question now. Take a look at this. Please pay attention here. Okay? Let X denote the number of horses being used on the self-service island at a particular time. And let Y denote the number of horses on the full service island in the use at the time. In a service station, the joint PMF of S and Y is given as this. Oh, this time around, we take a look at this. S and Y have the same levels, 0, 1, 2, 0, 1, 2. Now, let's take a look at what they give you in the table. Represent the probability of the joint. Please take note. What they gave you in the table represent the probability of the joint. This represents the probability of the joint, putting into consideration different level of S and Y. Now, what was the question? Please pay attention. Look at question A. Given that x equal to 1, okay, determine the conditional PMF of y. Let me tell you this. In exam, you are not going to see, you're only going to see this guy. You are going to be the one that will decide on what do you want to do, okay? Or how do I know is this? Because given that x equal to 1, what is the conditional PMF of y? That is f of y given s. You already know s. F of y given s. Now, s is no longer a random variable because s is given. Y is a random variable. Now, you now need to go back to the table. What is the possible values for y? I'm going to get for 0, I'm going to get for 1, I'm going to get for 2. And take a look at this guy now. That was why, oh my God, that was why we said 0 giving 1, 1 giving 1, 2 giving 1. Because 1, the values of s is already 1. And what is going to vary now is the one for y. Does that make sense? And that's what you're going to find. How do we find it? It's right here. When s equal to 1, okay? When s equal to 1, I'm going to quickly show you this. You know what we want to find? The probability of y given s equal to 1 is going to be probability of y, okay? Now, given that s equal to 1, divided by the probability of s equal to 1. Okay, if you want to go by the formula, this is the joint, and of course divided by that. Now, if you let's look at the denominator. When s equal to 1, okay, s equal to 1, okay, s equal to 1. Can somebody, what is that? When you had that up for s equal to 1, what is that? This plus that plus that. What does that give? Calculator? I just wanted to confirm something. When s equal to 1, what do you have? 0.34. And that was y here. Do you see the denominator here? Do you see the denominator for each of that? Do you see the denominator for each of that? 0.34. Okay? Now you're calculating this. But for this, you're going to get different values because here, if this is going to be when y equal to 0, giving s equal to 1, you need to find it. Y equal to 0, s equal to 1 divided by this. Another one, when y equal to 1, giving s equal to 1, you're going to find it. Okay, when y equal to 2, giving s equal to 1, you're also going to find it. So what has happened now? What has happened now? Y becomes a random variable. You consider y over the range of y. Does that make sense? And if you want to find this one out, you just need to go to the table. How do they get the 0.08? Okay. How they got the 0.08 right here? That is when y equal to 0, s equal to 1. Let's go to the table. Which is this guy here. In fact, you know what is going to happen? The first one is just going to be this divided by total. The second one is going to be this divided by total. The third one is going to be that divided by total. And that's exactly what you have here. Does that make sense? That is how to find that conditional. Now, the same thing, if you want to find y given a y equal to 2, the same thing. Okay? And that goes all the way. If you want to find y less or equal to 1, giving x equal to 2. Y less or equal to 1 is just to consider 0 and 1 for y. Okay, that was why you see 0 given 2, 1 given 2, and you get that. Okay, and every other thing is going to be easy. I think I'm going to stop here. I'm going to continue from here tomorrow. Is there any question? These are just further examples that we have. But if I were you, so tomorrow is only going to take us to conditional mean, conditional variance, and stuff like that, all the way